Hi, this is a video about percent composition of chemical compounds. So any compound, you can actually calculate the percent by mass of the elements that are in the compound. So this example is sucrose, table sugar, and you can see that the percent of oxygen, carbon, and hydrogen, they all add up to 100% about. Kind of depends on rounding, but what we can do is we can calculate the percent composition of any element in a compound by taking the mass of just the element divided by the total mass of the compound and then multiplying by 100. So, example. So here's an example where we have a compound that's made up of zinc and oxygen. So it's a 20 gram sample. That's the total sample mass, and that's going to equal the mass of the zinc and the mass of the oxygen. So I know in the question they tell me that I have 16.07 grams of zinc, so then I can calculate my mass of oxygen by just subtracting. So I would get my mass of oxygen is just going to equal 20 minus 1607, which would give me 3.93 grams. So now I know the mass of the oxygen and I know the mass of the zinc. So I can figure out the percent by mass of each of them. So if I want to figure out the percent of zinc in the compound, I'm going to take 16.07, because that's how many grams of zinc there are, over the total sample, which is 20.00. Multiply that by 100. So when I do that, I get 80.4% zinc. And I'm not really worried about sig figs. I'm just going to go to the tenths, kind of to be consistent with these. To calculate the percent composition of the oxygen in the compound, I would take my grams of oxygen divided by the total grams of the compound times 100. And when I do that, I get 19.7%. So you can check, that you did this correctly if these two numbers add to 100 or really close to 100, and they do. Let me show you another example. All right, so I want to just show you one other type of percent composition problem. So here is one where all you're given is the formula of the compound, and they want to know the percent by composition by mass of the elements that are in the compound. So the first thing I do is I calculate the molar mass. So it is Cl2O7, and I list my elements. I have 2 chlorines, 7 oxygens, molar mass, and I total them. So when I total them, I get 182.9 grams per mole for the molar mass. Sometimes I write these out, and I'll show you why in a second. This is just my work. If I were to take 2 times 35.45, the molar mass, by the way, of chlorine, and 7 times 16, which is the molar mass of oxygen. By having these handy, I'll show you how easy these can be. So if you're, sorry, I just have to add a page. So then when I want to calculate the percent of chlorine, I'm going to take the part of chlorine, which is 79.9, over the total mass of the compound times 100. And when I do that, I get 38.8% of this compound is by mass chlorine. So you see how it's helpful. If you had showed that work, then you just bring it down. You don't have to, though. Percent of oxygen, similarly, you would take the 112 the molar mass of just the oxygen. Notice I'm not putting my grams per mole in. Divided by my 182.9. So it's the mass of the oxygen compared to the total mass of the compound times 100. And when I do that, I get 61.2%. And again, double check. These add up to 100 or close, then I know I probably did it right. Let me show you one more. And this one is from the worksheet. It's 1B. So here's another, and you could try it and then, pause the video and then see what you get, if you get what I get. And I'm also going to pause it. So this is that problem number 1B on your worksheet. So I kind of accelerated it a little bit. And I'm calculating the molar mass, taking the fact that I have 1 barium, I have 2 nitrogens, and then you can see that I would multiply that, and I have 6 oxygens. And I did show the masses of each of those, and then totaled them. So then, to calculate the percent barium, I'm going to take the mass of just the barium in that compound over the total mass times 100. And when I do that, I get 52.5% of the compound by mass is barium. Then I would do nitrogen. Nitrogen is, 28.02 because there's 2 of them, divided by the mass of the compound times 100. And then I get 10.7%. And then lastly, I have the oxygen. And the oxygen's mass was 96 grams per mole, divided by 261.35 grams per mole. And when I do that, I get 36.7. So just taking the compound, calculating the molar mass of the whole compound, which I keep using as my denominator because I'm figuring out the percent of the whole. So the whole is the mass of the whole compound, whereas the top number is just the part of that element's mass of the compound. And then again, you can always double check, add those up, and they should be about 100%. I hope that helps you guys to be able to do percent composition problems.